This is a trick problem, a variation of which may appear in GRE or other standardized test. And this is considered one of the hard problems, but if you really break it down, this is not really that hard, but it's definitely a little bit tricky. So the problem goes as follows. Which of the following is the smallest non-prime positive integer that is not a factor of factorial 50? And we are given 5 options. So this is the typical multiple choice type of question. And we have to choose the right answer from those 5 options. Now, what is factorial 50? Well, factorial 50 essentially is the product of all the positive integers starting from 1 through 50, right? So we have to now find the smallest non-prime positive integer from the list given that is not a factor of 50 or factorial 50. And I must admit that when I first, attempted this problem, my instant reaction was to pick 51 because 51 is not present from 1 through 50. But when I thought just one level deeper, that would be the wrong answer in this case. And why? Because when you are looking at all of these options, the best approach to decide whether or not a given option is a factor of factorial 50 or not is to break each of these options into its constituent prime factors. As you know that each integer can be broken up into its constituent prime factors. And I'm saying each non-prime integer. So that's kind of already given in the problem, and all of these options are non-prime. So let's break up 51. And 51 can be broken up as 3 multiplied by 17, right? And now it becomes clear that both 3 and 17 should be there in factorial 50, because factorial 50 is the product of all the consecutive integers starting from 1 going through all the way to 50. So 51 clearly would not be the correct choice, though my first instant reaction was to pick 51 because it's not there in 1 to 50. Well, let's look at the second option, and we pretty much will do the same for every option. But 68 is basically 2 multiplied by 2 multiplied by 17. So 2 multiplied by 2 is 4, and 4 is there. And of course, 17 will be there too in factorial 50. So 68 is a factor of factorial 50. What about 87? Well, 87 can be divided or can be broken up into its prime factors, 3 and 29. And 3 would be there in factorial 50, so it would be 29 because they both fall among the integers from 1 through 50. What about 102? Well, 102, when you break it down into its prime factors, would be 2 multiplied by 3 multiplied by 17. And again, we see that 2, 3, 17, all of them are there in 1 through 50. So 102 is also should be a factorial, or should be a factor of factorial 50. Now, coming to the last option, 106, and by elimination, this would be the answer because we've already tested the first 4. But let's just verify that. So if you break up 106 into its prime factors, so that's 2 and 53. And 2 is, of course, there in factorial 50, but 53 is not there. So 53 is a prime number, and it is not present between 1 through 50. So it's not there in factorial 50. So 106 is therefore not a factor of factorial 50, and that will be the correct option for this question. Now, let's go over to another problem. So this is also a GRE type quantitative comparison question. where you're given two quantities, A and B, and you're asked to find which quantity or what's the relationship between the quantities. And we're given four options here. So this, again, these are, quadratic surds. So we're given like difference of two quadratic surds. And of course, one way to do this would be, can we estimate what root 2020 is, what root 2019 is, what root 2018 is, and then find the difference as given in the quantity A and quantity B and try to come up with a comparison. But that's definitely going to be a longer method that you don't want to waste time on, especially when you have a timed test. So what's the easier way of dealing with this? Well, whenever you are dealing with surds, especially quadratic surds like this, one thing to always consider would be whether you can multiply it by its conjugate and at least rationalize the some portion of the expression that you're given. So let's try to do that. So for the quantity A, if we multiply root over 2020 minus root over 2019 with its conjugate, which is root over 2020 plus root over 2019. So we have to divide by root over 2020 plus root over 2019 just to maintain the parity. And now the numerator of this expression will be 2020 minus 2019, and that will be 1. The numerator becomes 1, and then in the denominator we have root over 2020 plus root over 2019. And can we do the same thing with quantity B? We sure can. So for quantity B, again we multiply and divide by its conjugate, and in the denominator we have 1 because 2019 minus 2018 is 1. And in the numerator, we are left with, it's the other way around. In the numerator, we have 1. And in the denominator, we are left with root over 2019 plus root over 2018. So now we have to compare between the quantities in the box. And both of these quantities have the common numerator. So we have to find out which denominator is lesser to find the greater of the two quantities, right? Because if you have the same numerator, then the quantity with the lesser denominator will be the greater quantity of those two. And we can see that root over 2019 is the common quantity that's present in the denominator of each of these two. But one has root over 2018 and the other has root over 2020. And clearly the one with root over 2018 would have the lesser denominator of the two. So the quantity B actually has the lesser denominator when we convert the numerator to 1 by multiplying with conjugate, so that we reduce both the expressions to common numerator, and then it's easy to see that quantity B has the lesser denominator, and that should be the greater quantity, right? So the correct answer in this case is quantity B. So let's come to a third question, and this is a question on power and indices. And again, we're given the 36 to the power A equal to 54 to the power B equal to 81 to the power C, where A, B, C are positive non-zero numbers. Can we find which relation is accurate between A, B, and C? And we are given 5 options here to pick the right answer. So one common trick whenever you are given an equality involving 3 or more quantities. Usually an equation is between 2 quantities, but now you have a kind of an equality which involves three quantities and your unknown variables are there, a common trick is to, have the equality assigned to a common variable k. So let's call the variable k. So 36 to the power a is equal to 54 to the power b equal to 81 to the power c equal to k. And that can actually sometimes make things simpler and quicker and less messier. And we will see in this case. So now we have actually, a set of three equations. The first one is 36 is equal to 36 to the power a is equal to k, and from that we have 36 equal to k to the power 1 minus a. And similarly, we have from the other two, 54 is equal to k to the power 1 minus b, and 81 is equal to k to the power 1 minus c. Now we need to examine what these numbers 36, 54, and 81 are, and if we can find, how they're related between themselves, then we can potentially link the quantities in k in the same way. So let's start with 36, just because it's very easy to figure out that 36 is basically 6 multiplied by 6, so that's 6 square. And similarly, 81 is also special. It's a perfect square. It's 9 square. Well, 54 is not a perfect square, but it's very easy to see that 54 is basically 6 multiplied by 9. So essentially, by examining these three numbers, 36, 54, and 81, we observe that 54 square would be essentially 36 multiplied by 81. So square of 54 is the product of the other two numbers, 36 and 81. So now we know what k, or we know what 54 is in terms of k, a and b and c. So 54 is basically k to the power 1 by b. So that's k to the power 1 by b whole square on the left hand side. And then on the right hand side we have 36. So 36 is basically k to the power 1 by a. And then we have 81, which is k to the power 1 by c. And this basically becomes k to the power 2 by b, because when you square, your index gets multiplied by 2. And similarly, when you take the product, your indices gets added up. So k to the power 1 by a multiplied by k to the power 1 by c on the right hand side will be equal to k to the power 1 by a plus 1 by c. So we have k to the power 2 by b is equal to k to the power 1 by a plus 1 by c. And that implies that 1 by a plus 1 by c is equal to 2 by b. So the correct option in this case will be the option C.